Now, one of the reasons I have already pointed out that in nature the order already exists. You don't have to create it. Newton didn't create gravitation. Gravitation was there 1 million years ago. It will be there 1 million years hence. It's a law of nature. If we ask a more fundamental question, why nature is orderly? Why are there laws at all? Why are there definite cause and effect relationships? The scientist would say, I can't answer that question. I'm a student of nature. I have observed and I have studied, and I find that nature is orderly. But I can't give a reason why it is orderly. But that order already exists, and the scientist is merely observing it in operation and then deducing from it the laws which govern that order. So it's somewhat easier because you don't have to create that order. Whereas in consciousness, order doesn't pre-exist. It has to be perceived or attained through the ending of disorder. And therefore something has to be achieved. The elimination of disorder in consciousness has to be achieved here. There is no disorder in nature. Some of nature's happenings may happen to suit us, some others may not suit us. When it rains, it suits us because it waters all our trees and farms and so on. When it rains excessively, it doesn't suit us. But nature doesn't do something with an intention to hurt. Even the earthquakes, the storms that come, which destroy our towns, they are just the product of the laws of nature. And there is no intentionality in them to destroy. So there is no ego in nature. Sometimes it suits you and sometimes it doesn't suit you, what nature does. But when it doesn't suit you, it's not disorder. It is still following the laws. So we must understand that order just means that there are definite cause and effect relationship. Order there doesn't mean that would be convenient for us. Nature doesn't exist for our convenience. And scientists in the last 350 years have come upon a very definite method by which they investigate what is reality. And I want to illustrate that in the first slide here. First of all, one posits reality as the unknown. One doesn't take what one sees as reality, because you may see the earth is flat, more or less, but that's not a fact. The earth is really a sphere. You may see that the sun rises and sets, but that's not the fact. The fact is that the earth is rotating and therefore the sun appears to move around. So the reality has to be investigated and come upon. The truth is not just what is visible, is not the truth. It's hidden. So the method that was evolved was that first of all you must rely on observation, which includes measurement and recording very accurately and honestly details of the phenomenon that one is studying. The next step is that in the measurements, if there are two quantities where you see a correlation, that when this doubles, this always doubles, or when this changes, then the other one goes as the square of this, and so on. That's called an empirical correlation between two measurements. The next step is the real difficult step in science, and that is that the scientist has to guess the underlying model of reality. It must be such as to be consistent with the empirical correlations and the observations, and yet one is not sure that the model is true or is a true representation of the underlying reality. So, in theory, one deals with this imaginary model. There is the model of the atom, there is the model of a solid, there is a model of a liquid, there is the model of the universe. So always one is dealing with an imaginary model which is a guess about what the underlying reality may be. To this model, they apply the known laws of physics, they apply logic, and a form of logic evolved by the human mind called mathematics. And it's really a mystery why mathematics should apply in nature. In fact, Galileo went to the extent of saying that mathematics is the alphabet with which God wrote the universe. But it so happens that we have chance to discover that language of nature. And if we had not come upon mathematics, I don't think that physics or consequently chemistry and biology would have developed as much as they have developed now. But if we ask ourselves why mathematics applies in nature, we don't know the answer. It does. And so with the use of these, you develop what is called a theory. From the theory, then it must explain not only the observed facts which have been recorded earlier, but it should also be able to make new predictions of facts which have not been observed till now. And in order to verify them, one goes back to experiment and to observation. So there is a great emphasis on observation. There are three possibilities. Either the experimental results agree with the theory, then we know that the model that we have proposed is reasonably accurate, or they are not, they are a little bit at variance, then we know that the model is not exact but needs to be slightly modified or refined, or there is complete disagreement between what is predicted and what is observed, in which case you have to reject that model and guess again a new model of the underlying reality. That's where the creative ingenuity of the scientist comes, that what was the underlying reality is not known. It is posited as the unknown, and you are discovering, making discoveries in the unknown. Sometimes it is said scientists keep changing their mind, they keep changing their theory. Earlier they said there is conservation of mass. Now they say mass is not conserved, energy is conserved, but mass changes with velocity. So let them make up their mind, and when they finally have arrived at the truth, we will learn what they have to say. The mistake in that is that what was said earlier is not wrong, it is approximate. What Newton said was not wrong, we still use it to send rockets to the moon and for all practical purposes. But when you come across velocities comparable with the velocity of light, then these effects, the equations which Newton gave break down, and you have to use the relativistic equations of Einstein. So the science progresses through successive approximations to reality. You keep on refining the model. So the previous model was not wrong, but it is approximate. This one is a better approximation to reality. But actually, in theory, you never deal with reality. You always deal with a model, which is imaginary. You deal with reality only in experiment. So ultimately, they have to take recourse to experiment in order to confirm the model. So that is a method that is now accepted, that in order to discover what is real, you must do this by this method. And in the way this method has been applied, there are various values that have come about, which are scientific values. I have listed them on this slide. Posit reality as the unknown. Just as in religious quest, you must posit the truth as the unknown and not just go on stressing that your particular opinion or the particular illusion you have in your mind is the truth and do propaganda for it. So posit reality as the unknown. Inquire, observe, question. There is a great stress to observation, great importance of observation, and a great importance to inquiring and questioning, which also means that you don't accept on authority. It was not always so. After Aristotle, for nearly 2000 years, science didn't progress very much because they accepted everything that Aristotle said on his authority, and they never questioned it. And there were many things which he said which were wrong. So it is only in the last 350 or 400 years that this scientific method and the consequent values have become the accepted norm in doing science. So doubt all conclusions, keep an open mind, non-acceptance of authority, which means great respect for dissent. So something is not accepted as true just because Einstein has said it. Einstein is respected as a great scientist, but there are statements of his which turned out to be false, then they don't become part of science. For instance, he never believed in quantum mechanics, but we now know that quantum mechanics is true and that Einstein was mistaken. Which doesn't mean you don't respect him, because he, in his own right, he was but you don't accept something as true merely because a great authority or a great person has said it. You demand proof, you demand evidence, you do experiments, you test it by this method. So you demand evidence, proof, and reason. Objectivity is extremely important. You eliminate the observer, because the same experiment is repeated by many, many people. And if one particular observer, because he has given a theory and wants to support it, does bring in his desires into his observation, it will soon be discovered by other people who will then eliminate that, and it doesn't become part of science. So the scientific truths are independent of the observer. It doesn't depend upon who the scientist is. Science is independent of the scientist. Then seventh is the universality of truth. There is no such thing as African science and Indian science and Christian science or Hindu science. There is only one science. Either a stone is attracted by the earth or it is not attracted by the earth. It can't be that it is attracted for the Indian and not attracted for the American. So we have to question also why we have so many different religions if religion is really a quest for truth. Or is it just a propaganda that I am not interested in truth, I am interested in my brand of illusion and in propagating that. In which case we need to come back and look at institutionalized religion as byproducts of the religious quest and not mistake it for the religious quest. Truth is independent of time and space. Whatever is true, the laws that apply in the laboratory on the earth are the same laws which apply in the sun. They are the same laws that were there 1,000,000 years ago and that will be there 1,000,000 years hence. That is the scientific belief, if you like. And it has been tested because it is because on this assumption that they are able to build a whole theory of how the universe must have begun with the Big Bang and how the entire development took place and so on, that whole thing. And because it is consistent, it tells us that this is true, that the laws have not changed, and all we get from the stars is just a little bit of light coming in, and from the analysis of that light they are able to find out the speed with which that star is moving, the composition of that star and the temperature there, and all those details just from the analysis of the light, that comes to us. So that is the power of the fact that you can assume that the laws are the same out there as on earth. Eighth is reproducibility. It doesn't become science if it is just my opinion. It has to be demonstrable to everybody, and only that becomes part of science. So it's not an individual effort. I would like to add to it a ninth value, and that is international dialogue. Because we have posited the truth as the unknown, there is an international dialogue going on among all the scientists in the world. I do my experiments, I publish them in a journal. It's read all over the world. And somebody else repeats it. I don't even know him. I have no contact with him. But he publishes his results in the same journal, and I read them. And like that, we learn from each other. And ultimately, we want to he is also interested, and I am also interested in discovering the truth about nature. So there is an international dialogue with the truth posited as the unknown. That's a big scientific value also. I like Feynman's definition of science. He said, science is a body of knowledge, some of which is nearly certain, some rather uncertain, but none of it completely certain. That is, so many times we have felt that what we know is final, and then we have come across new observations and found that what we were thinking is wrong, that we are now not willing to assert that what we know today is the ultimate truth. So that is the spirit of great humility. True scientific inquiry begins with great humility because it posits the truth as the unknown. Now I said that these values can also be of great use to us in the religious quest, because in the religious quest also one must posit the truth as the unknown. One must rely on observation in order to discern what is true and what is false. You cannot do this kind of experimentation because here the observer is not separate from the observed, and that's the difficulty of the religious quest. When I am watching a pendulum or a body falling and so on, I can keep my desires out of it and just objectively measure and write down. But when I am observing my own consciousness, then there is an enormous interaction between the observer and the observed. Indeed, the observer is not separate from the observed, and therefore objectivity is extremely difficult in the religious quest. And there are subjective truths, and that is why one must be all the more doubt one's opinions and one's perceptions, because those perceptions could be distorted by one's own desires and one's own preconceptions. I have quoted here in this slide some of the statements of great scientists or physicists. Galileo said, mathematics is the alphabet with which God has written the universe. Heisenberg said, science points to some central design, some purpose in the universe. Einstein said, the religion of the future will be a cosmic religion. It should transcend a personal God and avoid dogma and theology. Covering both the natural and the spiritual, it should be based on a religious sense arising from the experience of all things natural and spiritual as a meaningful unity. Schumacher said the modern experiment to live without religion has failed. Schrödinger, he was also a great student of Vedanta, says, I consider science an integrating part of our endeavor to understand the one great philosophical question which embraces all others. Who are we? I consider this not as one of the tasks, but the task of science, the only one that counts. In other words, you have to explain both the body, the origin of the atoms, the molecules, the chemistry in the body, all that, the biology, and also you must explain consciousness ultimately. As yet, consciousness is beyond science, beyond hard science, because the scientist uses consciousness to do his science, but his science can't tell him what he is using, because they are not able to measure consciousness, and therefore, since science deals only with the measurable, the immeasurable lies beyond science. And that's why consciousness right now lies beyond science. However, scientists are making a lot of efforts from 3 different directions to understand what possibly consciousness might be. One of them is to make more and more complex computers. And it's a big question whether computers can also have a sense of beauty, can have feelings, can be made intelligent, can become creative, and so on, in which case they would imitate a human being. So, in other words, is a human being merely a very, very complex computer? Some scientists think so. There are others who think no. Computers have no awareness, and therefore awareness is what differentiates us from computers, which are purely mechanical. There are some quotations here from Albert Einstein. Science without religion is lame. Religion without science is blind. So he recognized the need for both. The most incomprehensible thing about the universe is that it is comprehensible. The most beautiful experience we can have is the mysterious. It's the fundamental emotion which stands at the cradle of all true art and science. It is in fact nothing short of a miracle that the modern methods of instruction have not yet entirely strangled the holy curiosity of inquiry. For this delicate plant, aside from stimulation, stands mainly in need of freedom. Everything is determined by forces over which we have no control. It is determined for the insect as well as for stars, human beings, vegetables, or cosmic dust. We all dance to a mysterious tune intoned in the distance by an invisible pied piper. Doesn't apply to elementary particles. We now know that there are uncertainties in behavior. Heisenberg explained that, but Einstein never really believed in that. So he believed in complete determinism. So that's how the scientific quest has progressed, and many scientists have also been philosophers and asking also questions about life. But science itself has confined its domain to that of the measurable. There is nothing that is anti-science in that sense, because if it's anti-science, then science would change. If something is not true, then science would change, because there is no adherence to any particular truth. If it can be demonstrated that it is false, it is dropped away.